Welcome back to the course Privacy and Security in Online Social Media on NPTEL. So what we'll do now is continuing the pattern that we have been doing for studying the analysis, studying how different kinds of patterns can be analyzed on social media. I'm going to look at this paper called On the Dynamics of Username Changing Behavior on Twitter. I think we've mentioned this topic briefly in the past, which is that how users actually change their usernames, why do they change, what level of frequency does the change happen, who are these people who are changing it, and what are the benefits by changing the user handles. That's what we are going to look at. This is an interesting paper which has some interesting implications also. So, in the abstract, it looks the authors say that past studies show that a substantial section of Twitter users change their username over time. And authors actually look at 8.7 million users on Twitter for a duration of 2 months. The data collection is slightly interesting and complicated also. We'll look at actually as we progress. So the high-level conclusions from the study is that few favor a username by repeatedly choosing it multiple times. So essentially what the paper would conclude is that there is a small set of people who actually change their handles many times, and there are a slightly larger set of people who change it very less number of times. And the paper also looks at the reasons why people actually change their usernames. As I've said before, abstract only summarizes what is in the paper. Then in the introduction, you talk about the whole growth of Twitter in terms of why it is how users are actually using it and what kind of data is being pushed onto Twitter. So that's what is being discussed here. So the conclusion that one of the conclusions that the authors have is in our data set of 8.7 million Twitter users tracked for 2 months, they observed that 73.21% users changed their profile attributes and assigned new values. About 10% of users changed their username in total. So this is basically showing you that about 73% of the users change their profile attributes and assign new values. So you can just see here that this is the x-axis is the different attributes and y-axis the percentage of users who have changed, and the color here mentions the different number of times that the changes were made. 2 means twice the value was actually changed, and then 3 times, 4 values, and 5 values changes. 73.21% of 8.7 million users change their attributes on Twitter, and just about 10% of the users change their username. So now let's look at the contributions of the paper. So there are 3 contributions in the paper. 20% of users trigger 85% of username changes. Again, this is the same Pareto principle that we have seen in the past, or a power law pattern. That is 20% of users trigger 85% of username changes. Observe to change 5 times or more Username changing behavior follows a Pareto principle. 10% username change occur after an hour of the earlier username change. I think the username changing pattern is also interesting because there are multiple reasons why people change. Right? People change because they want to get some space. For example, if at all, if my account when I started was Ponnurangam Kumaraguru, which is pretty long, and if I change the account to Punguru, I would start getting when users tag me or mention me in their post, they would get actually more space to write the content. And all this is happening just because there is space constraint in Twitter. Whereas in Facebook, if you see, there's a lot more space for the content, and therefore Facebook actually allows you to change your username only once. Twitter allows you to change as many number of times as possible. That's the reason why this problem is actually appearing. 65% of users choose a new username unrelated to the old name, while 35% reuse an old one sometime later. You'll actually see a table later also where there's a small set of people who actually collude, that is, in a group they would actually use the same name. Different users will start using the handle, the same handle within the group. The reasons to change username include benign reasons like space gain, suit a trending event, a gain or loss anonymity, adjust to real life events, avoid boredom, and malicious intentions like obscure username promotion and username squatting. I'll just tell you quickly what they are, and then when we go into the paper as we move forward, we can actually look at them in detail. Space gain, I said Ponnurangam Kumaraguru to Ponguru. Suit a trending event, there's some event that's going on. Let's take IPL, cricket, football. I would change my handle to look very similar to them, and therefore I'll get more of traction. Gain or lose anonymity. I create an account Ponguru, which is Ponnurangam Kumuru, which is probably very identifiable. Whereas if I have an account saying a guy from Chennai, the anonymity is pretty high. Adjust to a real life events, and things are changing in my life. So earlier, let's take, I was a grad student, I could have a graduate in my user handle, whereas now I'm a professor, so I could actually use professor in my user handle. Avoid boredom, it's boring since I've been using Ponguru for a long time. Malicious intent is user obscure username promotion. I could actually create an account which is change my user handle which is very similar to somebody who's popular, and actually get my handle promoted. And username squatting, I could actually register for an account called Amitabh Bachchan now and keep it for me whenever Amitabh Bachchan actually wants to create an account. They would actually have to take the account from me, right? This username squatting is actually a pretty popular problem in terms of usernames also. There was an incident even in India when the current government in Central wanted to have an account. There was an issue of PMO India. So squatting of that handle like Ponguru for somebody to actually use it is a problem, and this is a traditional problem in general domains also. Somebody could squat URL called pmoindia.in or pmoindia.com or apple.com, and they could actually have others to pay for it. I think there was an experience with housing.com when they wanted the domain. There was squatting for that domain name. So now let's look at actually the data set collection. So as I said before, in related work, there's a mention of three different types of domains in this, three different areas that this paper attacks, which is evolving user behavior, how users are actually changing their behavior online. And the second one is profile linking, which we've seen in this course before, in terms of actually connecting to user handles and finding out whether they're the same, identifying malicious. All these three different types of domains actually come into this research work. So the authors actually mention about these related work. Data collection. So in terms of actually the total data that was collected, the authors actually created a large seed data set, tracked the seed set for 2 months, every fortnight. Find users who change usernames more often than others, filter these users and track the profiles every 15 minutes. So essentially what others did was they took the large data set and they tried tracking it every fortnight, and for a small data set, small user set from this larger data set, they were actually tracking it for every 15 minutes. We'll actually explain later why this is this approach. Authors took this approach. So 8 million users who participated in the 17 local and global events during April 1, 2013 to September 3, 2013. So essentially there have to be some ways of collecting the users. So one approach that they took is events between April and September 2013. All the people who posted about these global events, the handles were taken, and they were actually the data for these 8.7 million users were collected, which is about their user handles. Seed tracking. Now from now on, 8.7 million users is the seed users. 8.7 million users for any username changes by querying them every fortnight within a period of October 2013 and November 2013. Right, so 8.7 million users every 14 days, go and check whether they have actually changed their handle. By comparing two consecutive scans, old and new usernames of a user were recorded, which is if 14 days before, if my account was Punguru and today my account is punurangam.kumaraguru, both of them are actually captured. Twitter usernames are case insensitive, therefore any case changes were not counted as username changes. We found that 853,000 users of the 8.7 million users, which is about 10%, changed their username at least once during a small observation period of 2 months. Right, in this 2 months, 10% of these 8.7 million users changed their user handle, which is actually pretty large, 10% of users changing their user handles. So now, how do you, meaning we can't actually collect all the users, 8.7 million users for very frequent data collection. So the authors actually decided to sample. So tracking users who do not participate in such behavior had little value, which is the users who don't change their behavior. We therefore filtered users of 700 700,000 users who change their username at least once, and randomly sample 10,000 users to monitor them for a short interval. The idea is to find out people who are changing their usernames, and from there take the usernames and create a small sample to collect data. And the big reason why you want to actually, the reason why authors actually chose to collect a smaller data set of only 10,000 is that if you were to make so much of API calls to Twitter, it is going to be impossible. So that's what they call. That's what the authors say here. If you look at it, quicker scans would need 1,462 application authentication tokens, and therefore it's going to be actually hard to do that. Okay, now that we've seen the different types of seeds that the authors used, here is a table that actually gives you the details in a succinct form. Fortnight scan October 16th to October 16, 2013 to November 26, 2013, 8 million users. 15-minute scan November 22nd to January 22nd of 2015, 10,000 users. Okay. Out of the 10,000 users, 4,198 users changed their usernames at least once in 14 months, constituting 14,880 username changes. About 20% users changed 5 minutes or more, triggering around 12,648, 85% of username changes. Right. So we'll see the figures also. So one user changed her username 113 times in 14 months, which on manual inspection turned out to be an inorganic user with half completed tweets with the same text, and frequent posts in short duration. So it's essentially saying that it's not necessarily a legitimate or a human being user. So the conclusion that you want to remember is 10,000 users, 4,198 users changed their username at least once in 14 months. Right. So the reference here is to figure 3. Let's go look at figure 3. So here is figure 3, which actually shows user distribution for frequency of changing usernames. 20% of the users frequently changes usernames, and 80% of the users change rarely. So again, like the last week paper that we saw, it's a percentage of users where you can actually see that the first part until about 10 or 12 is actually very short. So the inset is actually giving you the more detailed view of the data. Frequency of username change versus number of users. Okay. So one user changed it in 113 times in 14 months. Around 20% of the username changes were triggered within a day of the previous username change. Observe a Pareto distribution with 20% of the users frequently changing usernames in short intervals, and 80% of the users changing rarely after long duration. So this is in figure 2a. That's the distribution that you want to actually look at. So again, there is an inset here to show the number of days for a username change. This is 0 to 600, whereas this is just showing you 0 to 1, and the frequency of username changes here, right? This is the percentage of username changes. So A is giving you that. Normalized longest common subsequence length. We'll see all of this. Position of change relative to old usernames. Right. Okay, so now let's look at the usernames itself. Specifically targeting only looking at the usernames, we actually see popularity versus frequency change. We measure popularity of 4,198 users using followers, that is in degree. You know what in degree is. And plot it against the frequency of username change, which is number of followers that I have versus the number of times or my username changes. This will actually give you interesting results, like whether popular users who are having a lot more followers are actually changing their usernames more frequently versus people who have lesser number of followers. To find the correlation between the two, authors basically removed everybody who had greater than 1 million followers and two less, which is less than 1 followers, because there's no sense in having both these types of users, because it will actually not, it will basically skew the analysis that we're looking at. We observe that username change frequency is weakly yet positively correlated the in degree of username, which is a significant positive correlation implies that higher the popularity, higher is the frequency of change. However, weak correlation does not guarantee the same, which is that in this case we only have authors only found weak correlation. So there may be a chance that the number of in degree followers is actually affecting the username changes, but it may not also affect it. Figure 4a. So if you see here, this shows number of followers from 1 till 10 to the power of 6, frequency of username changes. So there's not a really, meaning if it would have been a positive correlation, we could have actually seen all data like this, which is as the number of followers increases, first percentage of times the username changes increases, then it could have been a linear graph, whereas this graph is showing you that it's not really positively correlated. So if you look at this another metric, which is percentage of tweets posted versus frequency of username change, weak correlation imply that popularity and activity has a little impact on choice of changing username, which is the second graph is here. Figure 4b shows the frequency of username change with the user's activity. To find correlation between the two, again removed greater than 10,000 tweets, less than 1 tweet. We observed a weak and a positive correlation between the two. Same as the number of followers, there's only a weak correlation between these two, number of tweets posted and the frequency of username change. So that gives you a sense of, so let's go over all the analysis that we have seen until now. It basically says that 20% of the users change 5 times. There are people who have changed 113 times. And there's a weak relationship between popularity and the number of posts somebody posts for the username changes. That's what we know until now. So for studying actually the reasons why people change the name, Pardi, who is the first author of the paper, actually tried doing some interesting things. One, she created a survey with some questions asking why users actually change their usernames. And she posted tweets tagging the users who had actually changed their usernames. Interestingly, we got some both very positive reactions and very negative reactions also. There were people who actually said, why are you actually tracking us? Who are you? And why are you actually understanding the username changes that I have done? Why are you asking me all these questions? Some users actually reacted with their gave their reasons why they are actually changing their names, usernames, and actually explain things. Here is some reasons that we said in the abstract. What are the reasons that people could actually change the username? Space game, of course. Ponnurangam Kumaraguru versus Ponguru would help them change their get more text into the posts. Let's also look at the figure 5, which actually is showing you that the length difference between the names. So if you look at the x-axis, it's a space gain being in the x-axis, and y-axis old username length, which is to find out that if I moved from Ponnurangam Kumaraguru to Ponguru versus Ponguru to Ponnurangam Kumaraguru, what is happening and why are users doing it, right? So authors calculated the length difference between the new and the old name of users, and separately represents users with the old names less than and greater than the median length of 11. That was because I think the data set showed that the median length of user handle size was 11. Others observed that 75% of long usernames moved to a short or the same length new usernames. 75.19% of long usernames moved to short or same length usernames, while 60.87% short usernames picked long usernames. So it's kind of same kind of percentage of people are actually flipping from small to big and big to small. In other words, most users with old usernames of less than 11 tend to add characters in their usernames, while most users with old usernames greater than 11 prefer to remove characters from their new usernames. Old username length greater than 11, which is shown as red here. They're all moving from, so basically space gain, if I actually reduce the my user handle size, I'm getting actually more space. If I'm getting increasing the characters, I'm losing space. That's what is positive and negative here. It moves from, so old usernames, old username less than 11, where if you see here, old username less than 7 tend to add characters. So that's what is there, space gain, and this is negative space gain. Old username less than 11 characters. So this is blue is old username less than 11 characters. So they are actually getting space gain, which is positive. Old username greater than 11, which is getting they're adding more characters, so they're getting space gain negative. They're losing space. That would help you to understand what kind of username changes are happening on Twitter in terms of the 10,000 users that the authors were actually analyzing. Maintain multiple accounts. Few exchange usernames with their multiple accounts, which is I maintain 3 accounts and I actually keep changing the usernames between these 3 accounts. So the users, some users in the dataset change username to reverse the identifiability of the users, either to make them personal or to anonymous. So for example, I could actually have a username Ponguru, which is probably identifiable, and I move from Ponguru to professor from Chennai, and that would make it anonymous, compared to professor from Chennai to Ponguru, which will make it more identifiable. Yeah, so just take a look at this table. This is something I mentioned earlier, but I'll actually explain what happened in the data set now. So if you look at the first column, which is the ID, which is the unique ID that the users have on Twitter, we have put X so that you can also not identify the users for now. Scan 1, Peshawar underscore SMS. Scan 2, Peshawar underscore went to the next user in the row 2, and scan 3, Peshawar underscore SMS went to the user 3. So it's the same group, Sajan group, and given that we were actually tracking, the authors were tracking every 15 minutes, we could actually find out that every scan had the user handle with different sets of users from the same group. It could be the case that all these handles are actually managed by the same person. There is a probability there, but what we found was this, that usernames within a group have been shared, and people actually use different accounts starts using the same user handle. So the last column is date of observation, which is showing you that we captured data in different snapshots. So looking at the reasons for actually username changes are just two events, which is one user actually said that the user was actually associated with an event, the event finished, and the user started connecting with another event, and then so their handle was changed. For example, PWI fan club to Force India. So this is the explanation that I did with the table 2, which is the authors found that a few users collaboratively picked the same username at different timestamps, and the table I already walked you through, so which actually gives you a sense of how the handles have been managed. Username squatting. Username squatting is actually against the Twitter rules. But users actually generate the user handles and keep it so that they can actually monetize it when necessary, when other users are actually wanting to have these handles. So that ends the paper. So this is essentially a paper which talks about how much frequently the users change their handles, why do they change their handle, what kind of patterns, what is the relationship between number of who's changing the handle, people who are popular versus people who are not popular, people who post a lot more text versus people who post less text. That's the kind of analysis that this paper did. This paper can be actually very useful in terms of even analyzing and even making some inferences on username changes. So here is a table which actually also says a few reasons for username changes. Right? Privacy. For privacy, since as my initial and part of my full name. So essentially people have actually given the reasons for why people change their usernames. Privacy and abuse, link all accounts, use real name, use easier, shorter username. I'm reading the text in the column 1. Violates wiki policy, violates wiki policy for religious reasons. So these are not from the user handles from Twitter. Authors actually got a chance to look at the username changes in Wikipedia, and these were the reasons that people had actually mentioned. Even in Wikipedia, you could actually change your handle. Of course, this work, meaning all of these kind of work has to have some kind of a limitation. So here, due to the Twitter API restrictions, only 10,000 users data was actually collected and analyzed for the 15-minute scan. That's one of the biggest limitations for the study. And there are many directions that people could actually take this kind of work. One direction which users could take or people could take is actually increasing the data set of the analysis itself, studying it among much larger data set, probably may give some more results, which is generalizable to large audience also. With that, I'll stop this paper. I'll see you soon.